I'll just kind of give you a little bit of background as to who I am and what I do, and then I'll kind of go over our journey into Kotlin and how we implemented that at Crunch. So my name is Lee Turner. I'm the kind of lead backend dev at Crunch. So I'm part of the team that supports our backend technology stack. That is like our core accountancy application and our suite of microservices. There's a few places you can get hold of me there, my Twitter, my website. Again, shameless plug here, but we did organise back end of 2019 the Brighton Kotlin meetup, which Luke has been a pivotal part of helping out with that and supporting that. We use the Hayes offices when we're meeting in person, obviously not so much these days, but hopefully get back to that soon. So take a look at that. If anything in this talk today piques your interest in Kotlin, then by all means, come along. There's a wide range of people who come to that meetup. We've had talks from some guys in Worthing, the HMRC, and how they've implemented Kotlin. So it's been quite an interesting journey so far. We're looking to pick up some online talks as well in the next few weeks, hopefully. So take a look at that if it piques your interest. So before I delve into the Kotlin stuff, I wanted to kind of give you a bit of I wanted to frame kind of what we do at Crunch and why, just to give you a bit of context as to why we might want to look at something else or why we might not. On the backend team, we support two worlds really. We have the core accountancy app, which is your classic monolithic app that's written in Java. And over the past few years, we've been steadily migrating parts of that app into microservices. So again, all written in Java. So we're very well embedded and well ingrained into like a Java development workflow and kind of things like that. We chose Spring Boot to to build our microservices on, and they run on Kubernetes. And at the moment, we have around kind of 45-ish microservices, and I say ish because it's changing daily at the moment. We've got quite a few different teams all working on new services. We've decommissioned some services, and we've kind of thought that service is a bit too big, we'll break that up. So it's constantly in flux, but we have about 45 microservices in production at the moment. Now all those services are running on Java 13. So Java 13 is pretty recent. We are in kind of conversations around moving to Java 14. So, and I tell you this because it's not like we're on our microservice side anyway, stuck back in the kind of Java 8 world or anything like that. We have moved quite quickly to new Java versions. So we have the luxury of using some of the more recent Java features. So also worth mentioning, because it is relevant to our kind of dipping our toe into the waters of Kotlin, that we are lucky enough to have, I guess, what is more well known as kind of 20% time. We have like our personal development days, as they're called internally. These are where, like, one day every sprint, a developer can choose to look at something new or implement something that they've been thinking about. And that played a big part into our dipping our toe into Kotlin, because that's kind of where it all started. So those are the areas that I'm going to cover today. What Kotlin is and why we kind of started looking at it more seriously than just a 20% day or a personal development day. So I'm going to start off with what Kotlin is. Now, if you go to the kotlinlang.org website, this is what you're kind of shown right at the top of the web page. Basically, it's a modern programming language that makes developers happier, open source forever. Now, in all honesty, that doesn't really kind of give you a great deal to go on. Modern sounds cool. I like the idea of that. Obviously, making developers happier, all for that. Open source also ticks a good box for me too, but certainly doesn't give you enough to go on to make a case for implementing a Kotlin, or any new language for that matter, into a very busy development team that is well ingrained in Java. So we need something a little bit more than that. But just to kind of give you a little bit of history, Kotlin Kotlin was developed by JetBrains. So JetBrains is, or was, traditionally a tooling company. We use JetBrains at Crunch. It's our development environment. We write all our code on the backend team anyway, in JetBrains IDEA, IntelliJ IDEA. So we're pretty happy that JetBrains is a pretty reputable company. It's got a lot of backing. But interestingly, we're relatively new to the game, I think. Kotlin version 1 was released on 15th February 2016. So it's been around for a good number of years. It's not like this is it's a new language in terms of, programming language in general, but certainly not like, released last year or anything like that. So, which is a good thing. Google started supporting it for Android in 2017. And then May last year, Google actually announced that Kotlin is its preferred language for Android app developers. Now, this is relevant to us because we need to know that anything we invest our time in has the backing and support of some reasonably big organizations. It's not going to just disappear in a couple of months' time. Otherwise, we'd be investing our time and effort into something that wasn't as stable as we were hoping for. So if you delve a little bit deeper onto the kotlin.lang website, you'll find these 4 things as kind of like the main kind of premise of what Kotlin's all about. So it tries to be concise. It drastically reduces the amount of boilerplate code. It's supposed to be safe. It allows us to avoid entire classes of errors and exceptions, the big one being null pointer exceptions. It's interoperable, leveraging existing libraries that we use every day, and tool friendly. I guess the last one is pretty much a given that it's built by JetBrains, which is an IDE company. So I'm going to tackle these kind of one by one and kind of why it's important. Concise languages are important because we need to make every single line of code that we write count. I'm sure Crunch is no different to any other tech company. We write a lot of code. Every day we've got new services being created, new features being built, pull requests come out. We write a lot of code. So if our developers are spending, let's say, 20% of that time just writing boilerplate code, then they're not focusing on the high value activities that they could be focused on. So we need to make every line of code count. So apologies to the kind of non-devs kind of on the call, but I'm going to kind of go over some of those language features that kind of make it a little bit more concise, just to kind of give you a bit more of an understanding as to why this is important to us as developers. So hopefully you can see this. Here we've got some Kotlin code. The kind of top part is what we call a POJO, the kind of classic name for plain old Java objects. Now, they're generally used for storing kind of data, like here we've got a customer object. We might have an account or a general ledger or a VAT return or something like that. But they generally have a number of properties. Here we've got name, email, company. And they generally have a wide range of kind of boilerplate code around them. These include methods to get and set the properties of the class, methods to allow us to compare objects to one another, and things like that. So just to give you an idea, this one line of Kotlin would effectively translate to around kind of 65 lines of Java code when we're talking about all of the methods that we need to make a plain old Java object function in our programs. So that's a kind of huge saving in terms of what our developers are not having to write. Now, I guess you could always argue that our IDEs, our integrated development environments, help with that. We have the ability to kind of like produce code, or the IDE can write, produce the code for us. But if we don't have to worry about it, if we get that out of the bag for free, then that's much more preferable to us. Because even if our IDEs are generating the code for us, that code still goes into our source control. It still has to be reviewed by other developers on pull requests. So it has an impact and it has a cost. So one line of Kotlin you know, removing 60 odd lines of Java code. That's a massive win for us. Kotlin has, because it's a more modern language, it's been able to rethink the way it kind of supports developers in terms of just standard operations that we do every day. So the last three on this screen here are just filtering lists of data. That's really simple in Kotlin. It might take a few more characters to do that in Java. But when we talk about boilerplate code, we're talking about the type of things that are required to kind of just create objects, and simple things like in Java, every line of code has a semicolon on the end. Now, when you're writing thousands and thousands and thousands of lines of code, that's a lot of semicolons. It might seem small, but it actually makes a big impact. And the one there, we've got the converter. If this was Java, we'd have to specify the new keyword at the beginning, in front of that mapping Jackson class there. So again, the compiler knows about all of these things. It knows when a statement has ended. We don't need a semicolon. It knows when a new object is being created. We can drop that quite easily. So again, all of these things go towards making our code much tighter, much cleaner, and just less verbose with kind of boilerplate code. So here we've got an example of what's called single expression functions in Kotlin. So at the top, we've got a function written in Kotlin that adds two numbers together. Pretty simple. A function called add two numbers, takes two integers, returns an integer, adds them together. Single expression functions in Kotlin, you can reduce down to one line. So it makes it nice and concise. Because there's only one expression in that function, basically we get rid of the curly brackets. And we can take that even further. Kotlin knows what the return type is. It can infer the return type from the function. So we can remove the return type in that function as well. So we're basically just having to write less and less code to get the same impact from what we're doing. I'll go through these a little bit quicker. At the top here, we've got a couple of functions these are written in Kotlin, but this is kind of the patterns that you'd see in Java code. You see the function at the top, which basically creates a customer with a name, first name, last name, and the number of days payment terms that they might pay an invoice, for example. The function below that is a function with the same name, but it reduces the parameters by one. So we don't pass the payment terms in, but we set that as a default. So this is kind of like a convenience method, really, to allow us to create customers with just 28 days as the payment terms. To do that, we've created two functions. In Kotlin, that would just be one function. You can see there, here at least we've got default values for parameters. We've specified 28 on the parameter list, so we don't need the second function. That means that if I call that function in Kotlin, I can just pass in the first and last name. I can leave the payment terms off, and Kotlin would know that it would use 28 in those instances. The last line, just to follow on from the conversation before about single expression functions, again, that could be converted into a single expression function, remove the curly brackets, remove the return type, and you've got a one-line function with default parameters. Pretty cool. So Kotlin is classed as a safe language. Now, this is a copy. This was copied from Wikipedia. Tony Hoare. He basically called it his billion-dollar mistake. Now, if you've been using any programming language that has a concept of a null reference, you've probably been subject to errors in production. Null pointer exceptions. What this basically means is that an object that we've created, like the customer in the previous example, we expected it to have some data, but it was a null reference. It wasn't pointing to any customer object, and that was unexpected. Therefore, an exception is thrown. So various languages have this. Java is no different to that. So this has caused, as he says in the bottom there, this has led to innumerable errors and vulnerabilities, system crashes, which have probably caused $1 billion of pain and damage in the last 40 years. I can certainly attest to some of that pain, as can the developers on our backend team. So what makes Kotlin safe from, or safer from those kind of errors? Kotlin has language structures to allow us to mitigate things like null pointer errors. The compiler understands more about what our objects are supposed to be. So here is a simple example. We've got a greeting. By default, the string doesn't accept nulls. So if you try and assign a null to it at the top there, you get a compilation error. And that's captured in the compiler before we've even run our code or deployed it to production. So we're catching these exceptions a lot earlier. So you can see here with the null greeting, we've added a question mark on the end. That now means that that variable can accept nulls. So if we try and use those in our code, the compiler again will catch if we're trying to call a method on an object that is null. So we're capturing these things much earlier in our development lifecycle. The bottom one there, the compiler is smart enough to know that if we've checked an object is of a certain type, we know that we want to cast that object to the type. So we don't have to do that in our code. So that's a bit of a combination of kind of safe and concise. So how do we use this kind of new world of kind of null safety? Obviously, objects in Kotlin code can still have nulls. They're still around, but Kotlin provides a number of operators and operations that allow us to more safely work with these data types. The first one, called the safe call operator, we basically add a question mark. If the variable is null, it doesn't call the to uppercase. That makes normally in Java we'd have to do like a full check, is this variable null? If it isn't, then we can call to uppercase, whereas this just makes it very simple, very concise, and a lot safer with the question mark. It prints null because the variable is null. We can work with operations only if the variable is not null, using the Kotlin let the Kotlin let operation. Kotlin also has what's called the Elvis operator, which is used to provide default values when things are null. So here you can see we're assigning hi to the greeting if it's null. And you can combine safe operators, Elvis operators, and things like that, just to make sure that your code is much more resilient to things like null pointer exceptions. This bottom one, I'm not quite sure. We don't tend to use that one so much, but you can get Kotlin to throw a null pointer exception for you if you want to, but we tend not to use that. So all of these things go towards making sure that our code is much more resilient to those kind of errors that we see all the time in programming languages like Java. There's very much a concept of shifting left, and that kind of, by that I mean the things that we can catch earlier in the process cost less in terms of time, money, resources, all of those kind of things. So if we can catch these issues when we're developing on our local development machines, that's got to be the best scenario. If we deploy it into one of our staging environments, again, that is better, but we've still had to spend time deploying and so on and so forth. If these exceptions and errors are discovered in production, then that obviously has a much more costly impact to our customers, to the people trying to diagnose it, and things like that. So if we can shift all of these things left and trap all of these a lot earlier in the process, then that's much more preferable from our perspective, and from any business perspective. Crunch is no different there. So there's a whole ton more language features in Kotlin that I would be more than happy to kind of go into, but we obviously don't have a huge amount of time here today. But if you're going to kind of delve into Kotlin, definitely take a look at all of those things that I've just talked about there. But there's kind of named arguments, extension functions, scope functions, ranges, collection operators, backticking function names. So there's a whole ton of stuff that would be kind of great to kind of look into. So the third one on that list of features was interoperability. Now, this one for us was a huge deal. We, like I said before, we're a big Java house, so all of our code largely is written in Java. We've got a few other bits in Python for tests, but mostly we're looking at Java code. So anything that we introduce into our ecosystem, it has to work with that out of the box. We can't have any kind of changes or quirks that we have to work around. It literally just has to be, it works first time. We can't rewrite things just for the sake of rewriting things. So we're not going to say, okay, we're going to do Kotlin now, let's just rewrite all of our services in Kotlin. That's just never going to happen. We don't have the time or the resources or the inclination to do something like that. So working with Java is a massive thing for us, and Kotlin does that really, really well. It's based on the kind of Java virtual machine, so it works with all of your existing libraries, your existing code, and it kind of just slots straight in. So that works really, really well for us. And the third one, sorry, the fourth one was tools and support. And I've already touched on this. Kotlin was created by JetBrains, which is, you know, a tools company effectively. So we know that we've got first-class support. All of the backend devs at Crunch use IntelliJ, which is, I guess, in JetBrains' flagship product. But JetBrains also do Android Studio. So we knew that we'd get the support that we needed. We weren't using something that just wouldn't be supported in the tools that we use. So big deal for us, and Kotlin fits that really, really well. So that's kind of what JetBrains and Kotlin kind of plug us there. They're kind of like standout features, but there's a few other ones for us that we kind of wanted to consider. And Coolness is a bit of a weird one, I guess, but what I mean by that is we want to make sure that our developers are keeping their skills up to date, doing something different to kind of what they might do on their day-to-day stuff. So that's where the kind of 20% days or the kind of personal development days come in. We've had people look at Go and Scala, and this is where kind of Kotlin really made its way into our ecosystem. But we need to make sure that our developers are happy. So doing something new, trying something new out, it kind of helps with that, and that's kind of where Kotlin fitted in for us. I'm not saying it's necessarily cool, but for developers, trying out something new kind of keeps their skills fresh, keeps their ideas fresh as well, and that's kind of filters through all the code that they write from that point on. We've had some really cool projects come out of this. I think one of our developers recently built YubiKey support, so 2FA YubiKey support. All written in Kotlin, you know, it's 20% day. You know, that kind of stuff really, really works quite well. When we were looking at Kotlin, we wanted to make sure that it had a community that we could call on. Now we had a look around Brighton, and there seemed to be a reasonable number of companies using Kotlin, but there was nothing that kind of really brought everybody together. There was a London Kotlin meetup, so we created the Brighton Kotlin one. So that's proven to be really useful. We've got a really good idea as to kind of like where Kotlin is being used, what it's mainly being used for, and that's really helped us understand a bit more about the ecosystem and what's possible with Kotlin. So that played a big part for us, and we're hoping to kind of really push that forwards in the next few weeks and months. So how did Crunch introduce Kotlin into their ecosystem? So we started with making sure that our baseline was good. If you're going to introduce anything new into your ecosystem, you want to make sure that you've got a good suite of tests, and the tests are covering all areas that you want to refactor into Kotlin. But you can take this in baby steps. So, for example, you could convert your test classes into Kotlin. Don't touch your production code, just touch your test classes. And that means that you're getting some good exposure, but you're not really kind of dipping your toe into the converting production stuff into Kotlin. But if you are going to touch the production stuff, make sure that you've got good tests, good test coverage, and things like that. So that kind of goes without saying for any refactors, not just Kotlin, but it works well in this instance as well. A lot of times in the beginning, we just used the bog standard IntelliJ converter. There's an option in IntelliJ to say convert this Java class into Kotlin, and that works really, really well. Kind of gives you a good understanding of the language and helps you understand a little bit more about how you would do it yourself. So use that. Just make sure that all your Java code is annotated correctly with the not nulls, and then that converter does a much better job. But if you are converting things into Kotlin, then I'd probably recommend just doing that conversion. Put that out as PR. Don't try and build new stuff and convert at the same time. So initially, we kind of just sneaked it into a few projects, really. We kind of chose a few areas. The DTOs are a big one for us. That's a massive win in terms of reduction in lines of code. So we took a service that wasn't mission critical to the business, and we just converted a few bits to Kotlin. And that worked kind of well because it allowed us to kind of have what we call exemplars, which are basically reference implementations for the developers to say, look, this is kind of what we did over here. You could probably do the same kind of things in your services. These are the benefits that we found, like, we reduced the code base by 700 lines of code, or, we've been able to implement this in a much more concise way. So that worked really well for us, having kind of these reference implementations. And we also then started to build it into our build environment. So at Crunch, we predominantly use Maven for our Java services to build. Maven has the concept of parent or startup POMS, which are basically you include one dependency and it brings in a whole load of other stuff. So we started to build Kotlin into our dependency management system, which basically meant that developers could start using Kotlin right off the bat, didn't have to worry about it. All the dependencies were already there, basically. It works really, really well. So obviously testing plays a big part in what we do at Crunch. We like to have good test-driven development practices where possible. Because Kotlin just is interoperable with all of your normal Java libraries and things like that. We use JUnit and Mockito and AssertJ and things like that. Kotlin just works right off the bat with those. So there's nothing really that you need to worry about there. But there are testing libraries that kind of are Kotlinified, for want of a better word. So we quickly looked around and found a few that we liked, and they're working really, really well. There's kind of Mock-K for Kotlin and Strict, I think it's called, STRIKT, which is an assertion library written by a guy called Rob, who works at Netflix, Rob Fletcher. So testing works just as you would do normally. Pick your libraries and it all works really, really well. So as far as the results are concerned, we've seen huge changes over the course of the past kind of year and a bit. We've been using Kotlin for over a year. We've seen thousands of lines of code reduced from our code bases. We've seen our pull requests are a lot less noisy. There's less boilerplate code, which makes a big difference. We've been able to reduce the number of libraries that we're using. So some of the benefits that we get from Kotlin, you could achieve with other libraries like Lombok and Google Autoval. But we don't need to use those anymore. We get that for free from Kotlin. So yeah, we've been able to reduce some libraries from Apache and Google Guava and things like that. So makes a big difference in our code bases. I think if there was any challenges to this process early on, I think we're in a place now where Kotlin has just been accepted as one of the options that developers have, and developers are encouraged to kind of choose what they feel is best for the job. There's no requirement to use Kotlin, just as there's no requirement to use Java, so they can pick and choose as they see fit. But early on, we had some challenges in terms of adoption, because obviously our senior leadership team want to make sure that if we're building something, we have the skills in-house to support it, and so that means that we need to get some training involved, and nobody wants to support something in production if they don't fully understand the language that it's been written in. So we needed to make sure that the senior leadership team were on board with all of that, and they're very supportive of that. Obviously not rewriting things for rewriting things' sake. So obviously touching things where we might be making changes already, we can implement Kotlin in those changes, but we're not going to say, okay, well, that service is working fine in production, but I'm going to rewrite it in Kotlin. That's just never going to happen. And Kotlin supports all of that by being interoperable. So works really, really well. The interesting thing is, I guess we're keeping quite up to date with Java versions. So Java has a much faster release cadence now. Every 6 months we can get a new Java version. So it's going to be interesting to see how Java and Kotlin fare, because Java will obviously release new features much quicker. So maybe Kotlin will keep up. It'll be interesting, but like I say, we're getting the benefits of those things now from Kotlin, so we don't have to wait for Java to catch up anymore. And where next? So as far as we're concerned, we're in a pretty good place with Kotlin. We've got some really good solid use cases, DTOs, and certain areas where Kotlin really shines in terms of the 80-20 of the benefits that you get compared to the amount of effort you put into writing the code. But I think we're going to make sure we try and apply those lessons across the board to all of our services. We've focused Kotlin in certain areas where else I think we could spread that out. And we're in a position now where enough of our developers are happy and comfortable with Kotlin that they just write Kotlin without needing to write Java first, and then convert that into Kotlin via the IDEs and things like that. So making sure that we get the training for those people who want to get up to speed quicker. And Kotlin it's not just server-side. Kotlin predominantly shines on the mobile space. So there's a lot of areas that we could look into because we've got that grounding now in Kotlin. We could look at coroutines, Kotlin for JavaScript, Kotlin native, Kotlin multi-platform, mobile, and things like that. So the ecosystem is much broader than kind of what we use it for. And coroutines are a particularly interesting one. The whole kind of asynchronous non-blocking code is something that we've not really kind of delve too deeply in. So I think that is probably going to be something that we explore quite quickly. So basically, I would just recommend going and having a play, taking Kotlin for a spin. There's basically their playground. If you go to play.kotlinlang.org, you can basically have a play with any of the language features. There's hands-on tutorials and examples that you can look at and get up to speed pretty quickly. That's probably where I would start if I was going to do it all over again. But there's plenty of courses out there, stuff on Udemy and free things that people have put on. So I think there's a Kotlin for Java developers free on Udemy. Definitely take a look at that if you're a Java dev. And yeah, it brings a lot of benefits, so highly recommended. And that is me.